good. Okay. Okay. I'm going to continue on kind of where we left off on Monday. Now, I said a typical stoichiometry problem, it's got a chemical reaction, it's got some givens, it's got some calculated parts. So, for example, this one here, if ethane burns in excess oxygen gas, it produces water and carbon dioxide. And from that, we could ask how many grams of water are produced if 13.5 grams of carbon dioxide are produced. Okay, so first of all, these are the 4 steps like we went over before. Every single problem has got 4 steps, except for unless we're giving more than one given. Okay, I'm going to touch upon that at the end of lecture today and get into it big time on Monday. My God. My cough has been ugly today. Okay. So the first question is balanced equation. Well, is there a reaction? Well, let's look at here. It says ethane burns. That means there is a reaction. Okay. And normally I would give you the reaction. Here's ethane, C2H6. Oxygen gas produces carbon dioxide and water. Now, again, I mentioned excess oxygen gas. So when I say excess, that means the other thing is what's driving the reaction, okay? As soon as I say excess, I had an incident earlier today that's driving this cough. That's fine. Okay. As soon as we say excess, that means that this is in smaller quantities. That means that is going to drive what is produced here. Okay. So the key word here is excess. Okay. So this is the reaction. And the first step is balancing equation if there is a reaction. And there is a reaction. So let's balance it. And we balanced it before. And let's just balance it again here. So we have CH and O's. And let's get rid of some of this clutter here. Okay, so we've got 2 carbons, 2 carbons, 6 hydrogens, 6 hydrogens, 2 oxygens. We have 4 and 3 is 7 oxygens. Okay, so if we had 3.5 oxygens, that would give us 7 oxygens because 3.5 times 2 is 7. Okay, so that's balanced, but we have a fraction, so we've got to clear the fraction. That means we're going to multiply by the denominator of the fraction, which is 2. So that makes that, I'm going to do it in a different color. That makes that a 2. That makes that a 7. That makes that a 4. That makes that a 6. Okay, and let's do an inventory to make sure everything is balanced. Okay, we got 4 carbons, 12 hydrogens, 14 oxygens. Okay, we've got 4 carbons, 12 hydrogens, and we have 8 and 6 is 14 oxygen. So it's balanced. Okay. So let's go back up to the original problem here. It says, how many grams of water are produced if 13.5 grams of carbon dioxide are produced? What's given? We go to the number. Okay. And what's associated with the number? Okay. What's associated with the number is grams of carbon dioxide. So that's what's given. Let me do one thing here. Give us some more real estate. Okay. So 13.5 grams of carbon dioxide. Now, I don't know if you've been noticing, I've been using railroad tracks during this. You can also use parentheses. I think railroad tracks is a little cleaner, but from a logical perspective and unit cancellation perspective, the parentheses are fine. And one other note here. Your final is not a multiple choice. It's going to be like test 1. I'm going to give it to you. You're going to download it, do it, upload it, and then I'm going to grade it. So there's going to be a lot of your work here in terms of setup. Okay, now the setup, when you do it from scratch, and I'm giving you, say this problem is worth 10 points, 9 of the points are going to be this setup here. So you want to make sure that the setup goes well. If you get the correct answer, I'll give you another 10%. The problem is if you don't get the correct answer, I've got to figure out your logic from your setup. So if you don't follow my process or Beacon's process or any other processes that are straightforward to follow, and I can't follow your logical reasoning by which you got the wrong answer, you're not going to get a whole lot of partial credit, if any. So make sure that your setup for the final is going to be straightforward and logical. Okay, so here's the given, and we're trying to calculate water, grams of water. That's going to be over here. Okay, so first thing is we need to go from the given to moles. So always the first step is we're converting to whatever's given. We need to convert it to moles because the mole ratios from the balanced equation is the valid part. This is what makes everything talk to one another, is the molar relationship. So if it's not in moles, get it to moles. That's step 1. Okay. So if we're going from grams to moles, that's the molar mass from the periodic table. And carbon is over 1. Oxygen is 16 times 2, that's 32. Looking at 4401 grams per mole. Notice grams on the bottom, of course, it's got to cancel. Okay, so that gives us moles. Now we need to go from moles of CO2 to moles of water. And do that via the balanced equation. That's why we balance the equation. It's this middle step. If you don't balance the equation correctly, this middle step is going to be off. Hence, your answer is going to be off as well. Okay, so we need to have the carbon dioxide cancel, means it goes on the bottom, and we're trying to calculate the water. And what are those coefficients or molar ratios from the balanced equation? Well, water is 3, carbon dioxide's 2. Okay, and notice carbon dioxide cancel. That gives us now moles of water. We want to go from moles of water to grams of water. Okay, so water is 2 hydrogens is 2 O2 because they're 101 apiece. Oxygen is 16. So that's 18 O2 grams per mole. We want the moles to cancel. So we're left with grams of water. Grams of water is what we're calculating. How many grams of water produced? Okay. So we're converting the moles of the calculated to whatever we're trying to calculate it in units, grams, number of molecules, whatever. Okay. And we grind this baby out. Now, when we calculate this, we're going to multiply everything on the top, divide everything on the bottom. So that's 13.5 times 3 times 18.02 divided by 44.01. Hit the divide key again, because there's another one on the bottom, by 2. Okay, so we're looking at 8.29 grams of water. Okay. 3 sig figs, 4 sig figs, infinite sig figs, 4 sig figs. So our answer is going to be 3 sig figs. Okay, so that's called a gram stoichiometry problem. Are there any questions about that setup? Okay, so I want to stop sharing for a second and bop over to okay, so here is, do you guys see this? This is Canvas. You guys, does everyone see Canvas right now? Because I swapped Windows tabs. I was just making sure everyone's seeing it. It's modules, unit 5. You all see that?
Yes, I can see it.
Okay, cool. All right. So the reason I'm bopping over here, I just wanted to show you, I've given you a ton of practice. Okay, a ton. Now, this guy here, grams to grams, this mass to mass. Okay, there are quite a few problems there, including the answers. Okay, now these problems that say limiting reagent, okay, are multi-step problems. Okay, that's what I'm going to get into towards the end of the hour. But as far as fundamentals of this chapter, it is this worksheet here, the one I have highlighted. Oops, the one I had there, highlighted. Okay. Okay. Now these are these. As soon as I say the word limiting reagent or limiting reactant, those problems all involve Excuse me. Those all involve multiple givens, not one given, multiple givens. And there's some extra stuff you have to do for consideration whenever you have multiple givens. Okay. All right, so what I want to do is continue on and do one more problem and involving the same reaction, ethane gas burning to produce carbon dioxide and water. Only this time I'm going to say how many molecules are oh, I'm making curry tonight and I inhaled a bunch of curry powder into my lungs. Curry powder in your lungs is not designed to be inhaled into your lungs. Oh. I'm going to go over this one problem and I'm going to stop the lecture and then give you a follow-on this later this evening after this coughing subsides. Okay, how many molecules of carbon dioxide are produced at 3.45 grams of oxygen gas are consumed? Okay, so let's go back up here and let me do a copy and paste of this equation. Okay, so here's the balanced equation. Let me rewrite it here so it looks a little nicer. Okay, so we have 2 ethanes combined with 7 oxygen gas, gives us 4 carbon dioxides and 6 waters. Okay, so the problem is, step number 1, of course, is balance the equation, which we did. How many molecules of carbon dioxide are produced if 3.45 grams of oxygen gas are consumed? Okay, so we don't care about that or that. We don't care about it. It's in the reaction, but the problem is only about 2 things, okay? What's given and what's you want to calculate. This could be 29 parts to this reaction. Doesn't matter. What's given, what are we calculating? It can both be on the right side or can both be on the left side. Doesn't matter. Okay. Now, what are we starting with here? We're starting with oxygen. Starting with oxygen gas. Don't I sound great? I'm really in good shape. It's just the curry powder in my lungs is telling my lungs that wasn't such a good idea. Okay, so we have 3.45 grams, and that is of oxygen gas. Now, sometimes in problems, they'll just say oxygen. I always say oxygen gas, but whenever they say oxygen, because oxygen can't be by itself, it's always teamed up with another one. So it's diatomic, and it's always written as O2, okay? But again, let me repeat, I always, assuming I'm aware, I always put oxygen gas, so you know it's O2. But some textbooks and some classes you're going to run into, they may just say oxygen. And in your mind, you need to say, oh, that's oxygen gas they're talking about. Okay, so step 1 is always convert what you're given to moles. Okay, that's from the periodic table using the molar mass. Okay, so we're taking given, converting that to moles. All right. and grams have got to cancel. So that means grams goes on the bottom. Oxygen gas, it's 16 grams a piece, so that's 32 grams. Okay. The second step is we need to get from oxygen to carbon dioxide via the balanced equation. Okay. Oxygen needs to go on the bottom, so it cancels. Carbon dioxide is on the top. Okay, so that would be 4 and 7. Now, going back up here, we want to know how many molecules, not how many grams, but how many molecules. That is Avogadro's number, the 602 times 10 to the 23rd. Okay. And moles have got to be in the bottom, so it cancels. So this gives us molecules, carbon dioxide. Everything else cancels. And that's what our calculator is, molecules of carbon dioxide. Okay, so this is a setup. So let's grind this out and see what we get. God. Oh, sound like a TB ward here. Okay, 345 times 4 times 602 EE 23 divided by 32 divided by 7 gives us 3.71 3 sig figs. Okay, so 3 sig figs, 4 sig figs, infinite sig figs, 3 sig figs. Our answer is going to be 3 sig figs. Oh, goodness. Okay, so I'm going to end this here and do a second lecture this evening to pick up on when you have more than one given, when my cough subsides, which could be tomorrow, but probably, hopefully tonight. Okay, so any questions about what we've done so far? Okay. All right, so I'm going to end this. So you'll see 2 videos for today, or today and tomorrow, hopefully this evening. Okay. All right.